Hello, this is Kiran Kamble again. Today I'm going to talk about part 2 of chapter 5, which deals with quasi-experimental designs using both control groups and pretests. So let's begin. So matching through cohort controls is popular in public health and medicine. What is a cohort? Cohort is described in the book as a group of subjects, people with similar characteristics on some accounts and go through and those units that go through similar experiences. For example, students in a particular grade, employees in a particular factory unit, or residents of a neighborhood. So, what are the benefits of a cohort control groups with and why is it so commonly used? Cohorts are useful in studies as control groups due to presumed similarities and smaller differences with treatment groups than if you take a non-cohort comparison group. Although the match will be lesser than what you will get in a randomized experiment. Now, cohort control groups can be useful in following situations. One, when one cohort is given a treatment and earlier or later one is not. When the differences between the cohort is minor. 3. In cases where treatment is mandated to all the groups simultaneously. So to find a cohort, one has to look at historical control group. One has to look at historical cohorts. And fourth, when organizational records are available to tease out cohorts, control cohorts from the historical data. These are the cases where cohort controls are best useful. So what are the threats to validity when using cohorts as control groups? Following are some of the threats that are encountered. One is selection bias may occur as a presumed selection similarities may be significantly different. Though there is a presumption that the groups are matched, control and treatment, they actually may be very different. Second, correlation of unmeasured background characteristics or variables that are not measured may have some correlation with the outcome. Third, selection maturation and selection history threats may occur. Four, effect of concurrent confounding event may not cannot be completely ruled out. And five, seasonal or temporal confounding threats may still be present. So what are the remedies for these threats? Suggested remedies for countering these threats are: 1. Carefully examining the assumptions of smaller group differences. Possible correlation between unmeasured background characteristics and outcome should be considered. Assigning some maturational stage to the treatment and control cohorts if they are temporarily separated from different time zones, then it is important to assign same maturational stage. Fourth is consider the effect of confounding concurrent events and break down the cohorts for more specific analysis. Fifth is repeat experiments with different control cohorts if feasible. Sixth is direct measurement that can address selection and history threats. 7 is collecting pretest and post-test data whenever possible. 8 is design modification to better take care of the internal validity threat, means using various design modification that we'll see later. And ninth is cohort design to be supplemented with a no treatment control group. Let's move to the next slide. Okay. So how can we improve the cohort controls by adding pretests? This design of adding pretest to the control cohorts is similar conceptually to the basic non-equivalent control group design with pretest and post-test that we saw earlier in this chapter. Uh, there is a variation in timing and measurements in the control group. That is the difference between what we saw earlier in the chapter. As the diagram represents, this design entails two tests at different times in the cohort control in an earlier time frame and pre-test followed by a treatment and a post-test in the next time frame in the treatment cohort. So there are two tests for the control and then pre-test, treatment and post-test for the treatment group. Any difference in measurement between O2 and O4 could be assigned to the treatment. That's the basic concept of the design. This design could be further strengthened by adding pre-tests or including multiple cohort controls. The this the pretest that is used in this particular design strengthens the statistical power by allowing within subject error terms and enables better assessment of maturation and regression. History threat to internal validity may still remain if any particular event occurs between O3 and O4, as we saw earlier under the threats. This particular threat can be countered by recurrent institutional cycle design, as shown in the diagram, with three consecutive time periods, 1, 2, and 3, and two control cohorts. So you see there are two control cohorts in the diagram, and in the middle is the treatment cohort. So how can we improve the cohort controls with a non-equivalent dependent variable? And does this leave any threat still? So the threat of maturation in the cohort control design can be addressed by including a non-equivalent dependent variable that can be measured on the same units. That's why it's called dependent. Only maturation then cannot explain the difference in measurements between pre-test and post-test. So we can safely assign the effect to the treatment. Let's move to the next. So the textbook introduces three designs combining many design elements. Let's see what these are. So the three designs which combine different design elements are first, and these are basically done to design elements aim to improve internal validity, strengthen internal validity, and also improve causal inference. So the first design is untreated matched controls with multiple pre-test and post-test, non-equivalent dependent variables, and removed and repeated uh, treatments. That's quite a mouthful. So basically, this complex design entails the following elements if you look at it stepwise. Controls are matched with the treatment group, especially on the variables of interest, including pre-test measures are taken on the main variable. Next, multiple pre-tests and post-tests at similar time periods are taken on both control and treatment groups. Subsequently, treatment effects are measured on multiple non-equivalent dependent variables. Lastly, treatment is either initiated later or removed and reinstated later in some treatment groups. Such a design, by virtue of its complexity and magnitude, will render any alternative explanation negligible, if not eliminate such alternate explanations. So that's the strength of this complex design. Second design is combining switching replications with non-equivalent control group design. So as you can see in the diagram, this is another complex design which may entail introducing treatment to the control group as shown in the lower half of the diagram chart. The design may also include reintroducing treatment at a second time in the treatment group. The R in the chart or diagram indicates potential randomization element being introduced in both the groups. The third design is using an untreated control group with a double pretest and both independent and dependent samples. So as seen in the diagram, this is a randomized design. You see the R's in both the rows, uh, with the upper row showing cross-sectional measurements taken on independent samples. The parallel lines that you see in the diagram denote the independence between the samples. So these are different units from the same population. So the independent samples are both in the control and the treatment group. There is a double pre-test and three post-tests that are taken. The lower half shows a uh, treat, longitudinal survey on the same panel in both the control and treatment group. So these are dependent uh, variables, dependent groups. Same units are tested at each time. Although labor and time intensive, this design increases the power while helping to identify combined effects of maturation and testing. The next topic we are going to look at is propensity score and propensity score matching. So what is a propensity score? Propensity score, as we touched upon in chapter 4 briefly, is the probability of treatment assignment conditional on observed baseline characteristic. So it actually talks about the probability of which group a particular unit will be assigned to, whether control or treatment. This probability is usually derived from logistic regression of carefully selected predictor variables. Propensity score is used to eliminate or reduce selection bias. So what is the goal of creating a propensity score? The goal of propensity score is to mimic a random experiment by including all variables important for the selection process, including interactions and other non-linear terms, provided they are related to the outcome, even if in a weak manner. A variable may be included based on conventional knowledge, although it may not be statistically significant, it is still included based on theoretical knowledge about the presence of that variable or the importance of that variable in the study. Typically, higher than usual type 1 error rates are used. That is, p-value is less than 0.1 or 0.25 as against 0.05 that is typically used. So it's very liberal in these cases. Now, what is a propensity score matching? Propensity score matching creates a set of units for the treatment and control groups with the match set containing at least one unit with similar propensity scores in both these groups. So what are the benefits of this method, propensity score matching? Propensity score matching, by approximating a random experiment as we talked about earlier, eliminates several problems associated with observational data analysis. For example, reducing multiple covariates to a single propensity score makes it easy to match multiple variables simultaneously. So what is optimal matching as compared to standard matching? Standard matching is propensity score matching, and in standard matching, as we saw, or propensity score matching, one unit from the treatment and one unit from the control group is matched. Self-matching, however, leaves some differences between the treatment and control groups on the propensity score because only one unit is matched, so there will be some unmeasured variables. Therefore, optimal matching, recommended by Rosenbaum in 1995, is the preferred method. In optimal matching, either there are two situations that can happen. Either one, there is a single treatment unit and multiple controls that are matched. So multiple controls with single treatment unit, or a single control unit is matched with the multiple treatment units. Optimal matching basically works by reducing aggregate propensity score differences between the treatment and control group. So instead of one unit, multiple control if there is one treatment, or multiple treatment if there is one control. Let's move to the next topic. So the last topic we're going to talk about today is sensitivity analysis. So what is a sensitivity analysis? The best of propensity score matching may still leave behind some hidden biases, some unmeasured scores or variables, as we seen earlier. And this is harmful, maybe harmful to the results, ultimate results and outcomes in a quasi-experiment. Sensitivity analysis is a method to determine whether such hidden biases may be present. And most importantly, sensitivity analysis quantifies the extent to which those hidden biases will change a result of significant difference to, say, no difference, or a result that is of showing no difference to a significant difference. So what are the benefits of sensitivity analysis? One we just talked about. So it quantifies the effect of the hidden biases on the effect on the outcome. Two, it indicates the presence of unmeasured variables that affect the assignment of a unit to a treatment or a control group. What are the benefits of combining a propensity score matching and sensitivity analysis? So propensity score matching may indicate the presence of hidden biases and unmeasured confounding variables, while sensitivity analysis provides tangible information on the effect of such hidden biases on the effect outcome. So you see, together they provide a very powerful statistical tool in the analysis of quasi-experimental designs. That is all for today. Thank you.